Okay, welcome to another LaTeX tutorial. This one's going to focus on the Tikz package and specifically using nodes. And to do that, we're going to make this figure here. So each circle here is a node. And usually the way I make figures, so you have a caption here. So this is figure 1 for this example document. This is your actual document file, and then I'm just including the figure from a subfolder so that we can compile the code just for the figure itself, and then later on include it in the overall document. So we go to the folder. This is just an example of the code we're going to write. So you can see it's now the only thing being rendered. So we're going to start from scratch. So your starting point is you need a document, and what I do is by starting with a document class of Tikz and the options in a standalone, and you need the Tikz package, then you get a document that will only crop to whatever Tikz picture you make. So nodes work is, there's different ways to define them, but you have node, you have the name of that node, you have different options like what color it's going to be, where it's going to be anchored, etc., and then at a location, so a location in X and a location in Y, and then the content of the node. It could be text, it could be a picture, but usually it's text. So the first node I'm going to make is going to just represent the background. So we want a node. I'm going to call it BG for background. And I'm going to give it no options for now at 0, 0. So I forgot a semicolon, but it's still compiled. So we have our first node. So here the node is a rectangle, and that's it. But I want this node to just represent the whole page. So the way I do it is you can say minimum width 8.5 inches, minimum height equals 11 inches, and this can be millimeters, this can be centimeters. You can use whichever unit you want as long as you specify the unit. And we're going to say fill equals black, opacity equals 0.3 to make it, this will effectively make it gray. Okay, so now I have a gray background that is the size of a normal piece of paper. So this is one way to make it gray. Another way to make it gray is specify like a color like this. So this is like, I think 30% black. This might even give us the same color. Yes, okay. So this way it's 30% black, but now it's not transparent. So there are two different ways you can approach it. See, so now you don't have the opacity here. So I'll just leave it like that for now. This is our background. Smaller. Okay, so now we want our 4 nodes. All right, 1, 2, 3, 4. So we say node, I'm going to call it east circle. So I'm going to refer to this as east, north, west, south for right, up, left, down, like you're looking at a map. And that's just generally part of the convention that LaTeX will use for nodes. Okay, so east circle at, let's say 2 inches, 0, C. So now you see we've created a node over here, but we want it to be a circle. So we're actually going to use a similar concept to what we did to create the background. We'll say minimum width equals, let's say 3 inches. And we just say circle. Now it's a circle. And fill equals blue, opacity equals 0.2. Okay, so we have our first node here. So we'll do a similar concept for the rest. However, right now I would have to manually figure out what size is best here and just constantly play with them. But what we would want to do is make this a function. So we know we want to distribute it in 4 equal locations. So we can create variables. The first variable I'll show you is, let's say we just want the size to be a variable. So we'll say circle size. Circle size. And we create a variable by saying new command circle size. Let's say 5.5. Okay, so now this is a variable. So now we can do the same concept for these 4 circles. So I'm going to create 4 different angles, and then I want to create points, like the x location is just going to be some radius times the cos of these angles, and the y will be some radius times the sine of these angles. I'm actually going to get rid of the background for now so that it compiles automatically cropped and I don't have to zoom out like that every time. Okay, so we can manually find these locations, but we want it to be parametric. So we can create a new variable, and instead of manually entering it, we'll change it to our variable. I'm going to call it PN for point north. PN. So instead of having manually entered values, instead we have a radius times the cos of the theta we want to distribute it amongst these 4 theta points. And then we also need this command that I use called fp_eval to actually evaluate whatever is in the brackets as a number. And I think the units are default as inches, so I don't need to specify them. So now we can do the same thing for all 4 locations. I'm going to call this the east point, the north point, the west point, the south point. Then we can start making this parametric. Okay, so now we have our 4 circles. Now we want to create this text here. And this is why, even though we could have done this with a draw command, by using nodes, we can do relative placement of this text. So we want to anchor it like so it shows up anchored to the locations we want. So the way we do that is we say node, or EL, maybe east label, and then we say at EC dot east. And now this will anchor it to the east location of the node. So it shows up here, but we want it to be on the left. And the way we do that is we say anchor equals east. Syntax, so these double slashes will create line breaks. Now when I compile this, it still won't show up because we need to say line equals center. And I'm not entirely sure why that's the case, but that makes it so that these line breaks actually show up, see? And then we can do something similar for the rest of the nodes. And the last thing I'll mention is you can do even more interesting stuff with node placement, where I can say node, let's say fill equals red, at, and just like you would write an equation, I'm going to do an equation on the node locations themselves. So you can say, let's say north circle dot north minus say 2 inches, 2 inches. And now you can see I've placed this node in a mathematical relative way based on the anchor point of this north node. And you can get really custom with things like this, and place nodes based on data and a lot of interesting things, because this, as we saw, can also be a variable. So let's say this was data point 1, and I believe this will work. See? And that's it. That's all I wanted to show today about working with nodes.